Assalamu alaikum wa rahmatullah. I welcome you all to the ninth video. In this video, we will explain the weight of a man in an elevator. If you enter an elevator or a lift, as shown here, your apparent weight in the elevator varies. You have a scale in the elevator that record uh, your apparent weight. Here is you yourself in the elevator, and then this is the flow of the elevator. Your weight is acting downward, is represented by W, and then you feel the reaction force. Remember, your weight is the action. According to Newton's third law, there should be a reaction in the opposite direction from the flow of the leaf, and that is denoted by R. Your 2 feet feel the reaction RR, and then you have the weight here, your weight. And then here is a scale on the elevator, and it records your apparent weight inside the elevator. Okay, having said that, let's go through what is written here. They say two forces act on a man standing in a lift or elevator. The first force is the man's true weight, and that weight is represented by W, and we use mg to calculate it. That is why they say is equal to mg, acting vertically downward. Then the second force is the reaction R of the flow of the elevator on the man acting upward. So your weight is acting downward, the reaction is acting upward. Now, here is a summary of what's gonna happen. The first thing is that when the elevator is stationary, meaning when it is at rest, or moves with a constant velocity, whether it is ascending or descending, provided it doesn't have an acceleration, it moves with a constant velocity, acceleration 0, then we have this. What we have is your weight that is acting downward, which we say is mg, will be equal to the reaction you feel on your feet from the flow of the elevator. Hence, there is no unbalanced force on the man, meaning the two forces, they are equal and opposite, they will cancel each other, the resultant force on you will be 0. If the man is standing on a spring scale, the scale record his true weight. Now, the scale will record your true weight in this scenario when the elevator is stationary or moves with uniform velocity. Here, diagram A explains that A is 0 because the elevator is stationary or it moves with constant velocity. And then the scale here records your true weight. Okay, the weight of the scale is the same weight here that we have here. Okay, and let's consider this. This is 0 here, 1. Let's consider this as 0, and then this is 1, 2, 3, 4, 5, 6, 7. So it means approximately the weight is 3 Newton. I'm just using an example. Let's say this is 2, because this is 0, 1, 2. So we have 2 Newton here as the true weight. I know it's much small, but we're going to use this as an example only. Then the next thing is when the lift accelerates upwards with an acceleration A, the man standing on the floor also pulled up with an acceleration A. Unbalanced force on the man is given by, okay, let me explain that. What will happen is that if the lift, look at the diagram here, is the lift or elevator is moving upward, is ascending with an upward acceleration A upward, then in this scenario the reaction he feels on his feet from the floor will be greater than the weight W1. It will be greater than his weight. So it means there is unbalanced force. The two forces do not cancel each other. There is a resultant force, and the resultant force is equal to MA. MA, mass of the man, times this acceleration. And how do we calculate the resultant force from here? The reaction here minus the weight will be equal to that MA. This is why they say the force, which is unbalanced force, is equal to MA. And how do we get MA? The reaction minus mg, the weight of the man, because reaction is more than the mg now. So if we make R1 the subject of the formula, we only have to take it to this side and add MA to R1 so as to mg. So R1 equals MA plus mg. We factorize M and we have M into A plus G. You see? Therefore, the apparent weight W1 is the apparent weight recorded by this, okay, by our scale here. The apparent weight of the man when the elevator moves upward with an acceleration A is W1 equals R1, this R1, and this is equal to M into A plus G. And this means that the elevator will record a weight greater than the true weight of the man. That is why it is written here. W1 is greater than the true weight of the man when it is going up. Let me repeat this. When it is at stationary or moving with uniform velocity, the weight is the true weight of the man. But here, when it moves upward with an upward acceleration A, the weight is greater than the true weight of the man, because now you have R1 equals M into A plus G. So when you compare the two equations that say W is equal to this one, W is equal to mg, and the other one that say W is equal to M into A plus G, you see there is extension here, there is addition here, A, and that makes the second equation more than the first equation. So after the comparison, we see that W1 is greater than W. It means the man does feels himself pressing downward R1 on the floor with a larger force than when the lift is at rest. The man's apparent weight W1 as recorded by the scale will be more than the true weight of the man. See? Then the third thing, see, if the elevator accelerates downward, now the elevator has a downward acceleration, there will be an unbalanced force. Remember, we said here that if it is going upward, the reaction on the floor is more than the weight. But now, if it is going downward with a downward acceleration, okay, the weight is greater than the reaction. So again, the force is, there is an unbalanced force here. They do not cancel each other, but the weight is greater than this reaction. So we are going to say weight minus reaction is equal to mg. The weight minus the reaction will be mg. So this is why here you see that our F, the unbalanced force, is equal to ma. And how do we get it? Mg minus the reaction. So now we make reaction the subject of the formula, and we only have to bring it here and take this to the other side. It becomes negative, so it will be R2 equals M into G minus A, and this is the weight that will be recorded by our scale, apparent weight. So it means that since we have a negative sign here, it means that the scale now will record a weight less than the true weight of the man. They say the scale on which the man is standing will read this value W2, and when you compare these two equations, we see that the true weight of the man is greater than W2, and this is indicated here from the scale. You can see here when you count, this is 0 1 2, but here 0 1, you see, is less than the true weight of the man, and this one greater than the true weight of the man is here, and you see it goes beyond that. Okay, that is it. Then finally, okay, they say hence the apparent weight of the man will be less than the man's true weight. Okay. Finally, when the elevator is falling freely under gravity, this time the acceleration of the elevator will be equal to the gravitational acceleration. A equals G, and this happens when the elevator is cut off. Okay, and the man will now be floating. His weight will be 0 in the elevator. His apparent weight will be 0. The scale here will record 0. Can you see the scale? The pointer is pointing at 0, telling you that the man's weight is now 0. Okay, and you can use this when you use this equation. The W3 equals M into G minus A. Your G is also equal to A. A is G, so the